Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology, Module 2, Solar Radiation, Heat Balance and Temperature. Today we will be starting with Lecture 2, which is Insolation and Factors Affecting Insolation Distribution on Earth. The video is being recorded by Dr. Pallavi Upreti.
The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM-PG Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayam Prabha Channels of MHRD, New Delhi, India. Hello learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. In our previous lecture, we have already discussed solar radiation and electromagnetic spectrum. Today in this particular video lecture, we will be starting with the insolation and what are the factors which are related to the insolation distribution on Earth. So let's begin.
Let's start with the objectives of the video. The main objectives of the video, which we will try to cover in this particular lecture, is understanding the meaning of insolation, understanding the concept of solar constant, factors affecting the distribution of insolation on Earth, which includes Earth revolution and distance between Earth and Sun, the angle of incidence of Sun's rays, tilt of Earth and duration of day and night in different latitudes, and effect of Earth's atmosphere. Besides this, we will also be discussing as part of factors the solar cycle and sunspots and solar flares and their impact on the distribution of insolation on Earth. Insolation or incoming solar radiation is the proportion of energy which is received on Earth, on the atmosphere of Earth, on the surface of Earth. So whatever energy is emitted by the sun, as you've discussed in the previous lecture, all the energy emitted by sun does not reach the Earth. Only a proportion of it reaches the surface of Earth, reaches the atmosphere of Earth, which is called as insolation. So the insolation is the proportion of solar radiation received by Earth, both the surface and the atmosphere, because the Earth's surface receives only a part of this radiant energy, which is 2 units out of 1 billionth unit of energy which is radiated by Sun. And this insolation is specifically applied to the radiation which arrives on Earth's atmosphere first and then the surface of Earth, because atmosphere also has a significant role in absorbing the energy, deflecting the energy, reflecting the energy, and then whatever is left out after all these processes in the atmosphere, a proportion of it reaches the surface of Earth. So when we talk about insolation, we say that the proportion of energy which is received at the outer limits of the atmosphere and then the proportion of energy which reaches the surface of Earth. The incoming solar radiations are short wavelength radiations, as we've discussed in the previous slide also, because the sun emits bundle of energy which ranges from very short wavelength radiation to medium wavelength radiation and even to long wavelength radiation. But when you compare all the energy which is emitted by sun as compared to the energy which is emitted by the surface of Earth, the energy emitted by sun is still short wavelength radiation as compared to our outgoing terrestrial radiation. Therefore, when we talk in comparison to the energy emitted by Earth and the energy emitted by Sun, then we say that the energy emitted by Sun is short wavelength radiation as compared to the outgoing terrestrial radiation from the surface of Earth. So And the heat derived from solar energy is normally called as solar radiation. It is measured by the amount of solar energy received per square centimeter per minute. We will be discussing this in detail in the next slide. In order to calculate how much insolation is received on Earth, generally we consider the unit of area and unit of time. That is, how much amount of insolation is received on a unit area of space in a given time period. So that average is how much? The average amount of insolation received by Earth is approximately 2 gram calories per square centimeter per minute. So per square centimeter is the unit of area and per minute is the unit of time. And this average amount of insolation is received at the top of the atmosphere. So while calculating the average amount of insolation, we take the insolation which is received at the top of the atmosphere. Why? Because atmosphere also plays a very significant role in either scattering, reflecting, refracting the insolation which enters the atmosphere, and then after all these processes, a significant proportion of the energy is reduced, and then that reduced amount of energy is received at the surface of Earth. So it is also calculated in terms of Langley, which is called as 2 Langley per minute. This rate of radiation received at the surface of Earth from Sun is called as solar constant. It doesn't matter how much amount of energy is emitted in the Sun, the rate of energy which reaches Earth is more or less constant, which is called solar constant. So let's see the definition of solar constant. It is the amount of solar energy, solar radiation or solar energy received on a unit area of the surface facing the Sun. So facing the Sun at an average distance between Sun and Earth, which is 150 million kilometers. We've already discussed this, also called as 1 AU or 1 astronomical unit. And this solar constant is constant all the time, and the solar constant of Earth is how much? 1.36 kilowatt per meter square, and it is measured at the entry point at the outer limits of the atmosphere facing the Sun. So this is solar constant. The insolation received on Earth differs from place to place, from time to time, and there are certain factors which affect the distribution of insolation on Earth. But before discussing the factors in detail, I would like to just quickly highlight certain facts as we know about the Earth, about the atmosphere, about the Sun, which culminate into several factors affecting the distribution of insolation on Earth. Also, these factors does not work in isolation. They work in tandem together. All these factors together affect the distribution of insolation on Earth. So we just quickly will have a review of facts, what we know about Earth. On an average, the amount of insolation received at the Earth's surface decreases from equator towards the pole. We know that the equatorial areas are hot and polar areas
are cold.
We know as a fact that these areas do exist. Secondly, there also exists a temporal variation, time-based variation at the amount of insolation received at different latitudes at different time of the year. So as Earth revolves around the Sun, there is a latitudinal difference in the amount of insolation received over a period of years. Also, there is a variation in the amount of insolation received at the outer limits of the atmosphere and ground surface, because significant amount of insolation is also lost after entering the atmosphere and then reaches the Earth. So these facts we know about the Earth. Coming to other facts include that we know that Earth is the third planet from the Sun with an average distance of 150 million kilometers, which is also called as 1 astronomical unit. And the Earth is nearly spherical in shape, and it is tilted on its axis from the plane of its orbit around the Sun. We also know that Earth as a sphere is not straight, it is tilted at 23.5 degrees. Another fact is it rotates from west to east on its own axis, completing one rotation in 24 hours, and it completes one revolution around the sun in an elliptical path in approximately 365 days. So these are the facts which we know about the Earth, about the atmosphere, about the sun, and these facts will culminate to create factors which will affect distribution of insolation on Earth. So let's discuss the factors now. Coming to the factors affecting the distribution of insolation, considering the variation in the amount of insolation received and variation in the distribution of insolation, several factors have been found to affect the distribution of insolation on Earth. And those factors are Earth's revolution and distance between Earth and Sun. Second, the angle of incidence of Sun's rays. Third, tilt of Earth and duration of day and night in different latitudes. Fourth, effect of Earth's atmosphere. And fifth, solar activities, solar cycles, and solar conditions like sunspots and solar flares and their impact on distribution of insolation on Earth. So now we will be dealing with all these factors one by one in detail. The first factor affecting the distribution of insolation is Earth's revolution and distance between Earth and Sun. As we know that Earth completes one revolution around Sun in 365 days approximately, and the Earth revolves around Sun in an elliptical orbit. So when it revolves around the Sun, completing a revolution in 365 days, the distance between them changes over the course of Earth's 1 year revolution. There are time periods when Earth is very far away from Sun, which is called as ephelion, where the distance between Earth and Sun is somewhere around 152 million kilometers. And then there are time periods over a period of 1 year when Earth is very close to Sun, which is called as perihelion, where the distance between Earth and Sun is 147 million kilometers. And this difference in the distance between Earth and Sun definitely affects the distribution of insolation on Earth. Now here the short clips gives a very good picture about how Earth revolves around the Sun and how the distance between Earth and Sun constantly changes in this 1 year time period when Earth revolves around the Sun, where it is sometimes very close to Sun with 147 million kilometers distance, and sometimes it is very far away from Sun with 152 million kilometers of distance, with an average distance between Earth and Sun to be 150 million kilometers. Therefore, the distance between Earth and Sun definitely affects the amount of insolation which is received on Earth. The second factor is the angle of incidence of sun rays. As we know that our Earth is a sphere, and the angle between the sun's rays and the tangent to the surface of Earth at any given place determines the amount of insolation at that place. And we know that there are certain places on Earth which receives direct insolation, like the equatorial areas, whereas there are certain places on Earth like polar areas which received indirect insolation. So there are areas where you have vertical rays, just like at equator, which are direct and cover small area. Thus the energy received per unit area increases and more insolation is received in those areas, leading to higher temperature. As you can see in the diagram also, the sun rays are vertical almost over the equator. Therefore, the energy received per unit of area is much more as compared to the polar areas, which does not receive direct insolation, which received indirect insolation and form oblique angle. Therefore, the amount of insolation which is received is very less. So in polar areas, we receive oblique rays. At higher latitude or polar areas, which spread over large surface, you can see that they cover much more area as compared to the rays which are falling directly overhead near equatorial areas. And the amount of energy received per unit areas decreases because they are definitely covering much more surface area in the polar regions. Thus, less insolation is received and we have lower temperature in these higher latitudes. So the amount of insolation received and the distribution of insolation is definitely affected by the angle of incidence of sun's rays. The third factor is the tilt of Earth and duration of day and night in different latitudes. As we know that Earth is tilted at 23.5 degrees on its axis to its orbital plane, which leads to the difference in the amount of insolation which is received in different latitudes. So just imagine if Earth would not have been tilted each and every latitude, be it the equatorial region or the Tropic of Cancer or the Tropic of Capricorn or the polar areas would have received the equal amount of insolation throughout the year. But because of this tilt, the amount of insolation received at different latitudes changes during the 1 year time period when Earth revolves around the Sun. So at certain time periods in the year, we have longer duration of days, which enable ground surface to absorb more radiation, hence more insolation. While during other time periods of the year, we have shorter duration of days, which shorten the sunshine time, hence less amount of insolation is received. Therefore, the length of day varies at all the latitudes, Tropic of Cancer, Arctic, polar regions, and Tropic of Capricorn, and Antarctic and Southern poles, except the equator, where the duration of day and night does not change, mainly due to Earth's tilt, rotation, revolution, and parallelism, because even if the Earth is tilted on its axis, the amount of insolation received in the equatorial areas is still the same, no matter at any season of the year. So, except equator, there is a difference in the amount of insolation received latitudinally, and the tilt of Earth's axis is responsible for it. The diagram in the next slide will make it more easier to understand how the Earth's tilt along with revolution is responsible for seasons on Earth. The tilt of Earth along with the revolution of Earth around the Sun in 365 days is also responsible for the creation of seasons on the surface of Earth, and it takes full 365 days to complete one revolution around the Sun. It also rotates on its own axis from west to east and is slightly tilted at 23.5 degrees on its axis to its orbital plane, and it remains tilted in the same direction all year round as it orbits the Sun. It means that different regions of the Earth receive the sunshine differently at different time periods of the year when Earth revolves around the Sun. Because of these two processes working together, the seasons are formed on Earth. And during one entire course of revolution, the Earth is sometimes farther away from Sun and sometimes it is closer to Sun also. Now let's observe how seasons occur on Earth. When there is winter season in the northern hemisphere, the distance between Earth and Sun is very less, which is 147 million kilometers. But during this point of time, just observe, because of the tilt, the northern hemisphere is farther away from the Sun, leading to winter season in the northern hemisphere. So the Earth is at minimum distance from the Sun, but the northern hemisphere, because of the tilt of the Earth, is farther away due to the tilt of Earth. And the North Pole, observe, the North Pole is completely tipped away from the Sun, causing winter season in the northern hemisphere. And at this time period, the sunlight strikes the northern hemisphere at a shallow angle for a short time period of time. This is why winter weather is cool with short days and long nights. You can see that at equator, even at winter solstice, there is still 12 hours of day and 12 hours of night. However, just look at the North Pole, it is completely in a shadow zone and does not receive insolation for 3 to 6 months of this time period, and here the polar nights, 6 months of nights are observed in the polar regions. So as you move northward from the equator, the duration of daytime decreases, whereas in the equator it is equal. As against this, when we have winters in the northern hemisphere, observe that the southern hemisphere, the south pole, is completely lit because of the insolation, and we have 6 months of day in the polar areas in the southern hemisphere, and the duration of day increases as we move toward the south pole from the equator. Now, as Earth further orbits around the Sun, we move towards the springs in the northern hemisphere. Now, Earth is neither tilted towards nor away from the Sun, as day and nights are about equal length in this particular time period. So, at this point of time, it is also called as September equinox or March equinox. So, at this period of time, the Sun is neither overhead the Tropic of Cancer nor at Tropic of Capricorn. So at this point of time, the regions receive equal amount of insolation. 12 hours of day and night is observed at equator. So it is autumn season in the northern hemisphere and it is spring season in the southern hemisphere. As Earth further orbits and we make a way to the summer months in northern hemisphere, notice that the Earth is still tilted in the same direction. You can see that the Earth is still tilted in the same direction, only now the northern hemisphere is facing sun and the north pole is tipping towards the sun. So you can see that the north pole is completely facing the sun and the southern hemisphere tips away from the sun, and at this point of time the earth is at maximum distance from sun, that is 152 million kilometers, but the north pole is facing the sun. Therefore, you have 6 months of days in the North Pole and summers in the Northern Hemisphere, while the South Pole is in the darker zone with 6 months of night. So, even at this point of time at equator, you can see that you still have 12 hours of day and night. But as you move towards the Northern Hemisphere, because of the tilt of the Earth, you can see that we have summers and we have more duration of days and less duration of night. And in the southern hemisphere, we can see that there is short duration of days and longer duration of nights with cooler temperatures. So you can see here that because of the Earth's tilt, the seasons are reversed in the one revolution time period of the Earth. So this signifies the importance of the tilt of Earth at 23.5 degrees on its axis and how this impacts the latitudinal distribution of insolation on Earth and leads to the creation of seasons. This clip further showcases how the tilt of Earth and how the revolution of Earth affects the seasons on Earth. You can see here, observe how Earth is tilted on its axis at 23.5 degrees and it remains tilted in the same direction whole year round. But because the Earth also revolves around the Sun, the Earth's positional change during the course of its entire revolution creates seasons, leading to different amount of insolation received at different latitudes, creating summer, autumn, winter, and spring seasons in both the hemispheres. When we have summers in the northern hemisphere, we have winters in the southern hemisphere, and when we have winters in the southern hemisphere, we have summers in the northern hemisphere. So this is how Earth's tilt affects the distribution of insolation on Earth's surface. Another significant factor which affects the distribution of insolation on Earth is the effect of atmosphere. As we know that when the solar radiations reaches the Earth, first they are First, they enter the Earth's atmosphere and they are received by the outer layers of the atmosphere. They cross the entire section of the atmosphere and then reach the surface of Earth. So during this time period, the atmosphere, because of its composition, because of its layers, they significantly affect the amount of insolation which is received at the surface of Earth. So the atmosphere affects the insolation mainly in three ways. It either absorbs, or it scatters, or it reflects the amount of insolation which is received on the outer layers of the atmosphere. So as we know that in the electromagnetic spectrum, we have several wavelengths of radiation which are received at the outer layers of the atmosphere. Some are harmful to us also, like very short wavelength radiations like gamma rays, X-rays, and UV rays. So they are absorbed and they are reflected by the Earth's atmosphere, which reduces the proportion of insolation which reaches the Earth's surface. So nearly 6 to 7% of the insolation which is received is scattered, and because of the composition of atmosphere, because of the presence of ozone layer, because of the presence of clouds, dust particles, and several other phenomena which are occurring in the atmosphere, the insolation is absorbed, scattered, and reflected. We will be dealing about the effects of atmosphere in the coming slides, but just take it for now that the atmosphere has a very significant role. So just imagine if 100 units of energy is entering the atmosphere, only half reaches the surface of Earth, and nearly 49% is either absorbed, scattered, reflected, or collected in the atmospheric pool of the energy. And therefore, the composition of atmosphere, the layers of atmosphere significantly affect the amount of insolation which is received on the surface of Earth. The distribution of insolation on Earth at last is also affected by the source itself, that is the sun. The amount of radiation which is emitted by sun also fluctuates from time to time during the course of its solar magnetic activity cycle, which is a period of 11 years, where the sun sometimes have lesser solar activity and at other times has very immense solar activity, leading to fluctuations in the amount of radiation which is emitted by sun. So sometimes you have sunspots, which are temporary phenomena on the sun's photosphere that appears as spots or darker regions, and the energy which is radiation emitted by sun increases with increasing sunspot activities. So during this 11 years time period, you have very less sunspots and gradually the number of sunspots increases, followed by tremendous emissions of solar flares, which are sudden explosions of energy near sunspots, where the sun tries to readjust its magnetic field. So they are intense eruptions of electromagnetic radiations in the sun's atmosphere, tangling, crossing, or reorganizing of magnetic field lines, restarting the 11 years time period or solar magnetic activity cycle of the sun. So during this 11 years of solar activity cycle, there are periods of less solar activity and then extensive solar activity, which impact the amount of insolation received on Earth, because during maximum solar activity, we have tremendous amount of energy which is released from the sun's surface, and sometimes this energy also tangles with the magnetic field of the Earth. So the amount of insolation is also affected if the source which is emitting that radiation is going through a cycle of periodic lows and periodic highs. So during the period of solar activity cycle, we have periods of less solar activity, we have periods of extensive solar activity, which lead to differential emission of radiation by sun and hence affect the distribution of insolation on Earth also, or the energy received on Earth increases or decreases. Sometimes more or less it is constant. Okay, it is not affected, it is constant. Therefore, we have a solar constant also. Therefore, we say that it does not affect how much emission is taking place on sun, or there is less emission or more emission. More or less, the energy received on the surface of Earth remains same. But there are certain time periods of extensive solar activity where you have solar flare, coronal mass ejections, which sometimes impact the energy received as insolation on Earth. Incoming solar radiation or insolation refers to the proportion of energy, proportion of solar radiation which is received on Earth, which is received first at the atmosphere, then at the surface of Earth. And the average amount of insolation received by Earth is approximately 2 gram calories per square centimeter per minute. So in a minute, 2 gram calories per square centimeter, they are received on the surface of Earth facing the sun, and the amount of insolation received is more or less constant, which is called as solar constant, which is 1.36 kilowatt per meter square. Again, this is calculated at the outer margins of the atmosphere facing the sun, and it is constant, which is 1.36 kilowatt per meter square. But the amount of insolation received varies from place to place, varies at the outer margins of the atmosphere and the surface of Earth, and it also varies latitudinally. There is more amount of insolation near the equatorial areas and less amount of insolation at the polar areas, and this distribution of insolation received is affected by certain factors, which are Earth's revolution and distance between Earth and Sun, which constantly changes, affecting the distribution. The angle of incidence of rays is direct over the equatorial areas, therefore more temperature, and it is oblique in the polar areas, causing low temperature. The tilt of Earth along with the revolution leading to creation of seasons, leading to difference in the amount of insolation received latitudinally. Then next is the effect of Earth's atmosphere, which means that due to the specific composition and due to the different layers in the atmosphere, the amount of insolation received is significantly affected by this composition and layer arrangement of atmosphere, and only a proportion of it which enters the atmosphere, only a proportion of it reaches the surface of Earth. And last one is solar cycles, sunspots and sun flares. So along with all these factors, the factors in Sun itself, during its 11 years time period of solar cycle, there are periods of more solar activity and there are periods of less solar activity, which affect the distribution of insolation on Earth. So we have discussed in this video what is insolation, how insolation is affected by various factors which are present on Earth, on atmosphere, or even Sun itself. So I hope you liked the video and it was informative. Thank you so much.